Swansea, and he will present the paper on smart brushing for parallel coordinates.
So happy Thursday, everybody. My name is Bob Laramee, and I am presenting this paper on behalf of Richard Roberts and the team at QPC. So the real work here was done by Richard Roberts, who is a PhD candidate at Swansea University, but he was too scared to give this presentation. No, he's working now. He submitted his thesis and he's working, so he ducked out of it. And this is kind of special in the sense that it's a more applied paper, and it's being done in collaboration with an industry partner called QPC, Quality Plus Call Scan, which is a call center operator. So at VIS 2015, was anybody here at VIS 2015 and recognize that image? So Renata Raidu et al. Showed this image in their orientation enhanced parallel coordinates. And I think a lot of us had kind of a psychic moment, because this figure points to a very clear a future research direction at the time, which is basically what this paper is based on. If you look at it, it shows kind of a progression from point-based to 1 point to 2 points to 3 point based brushing. So it's kind of very obvious where that could go forward. So the basic idea behind this paper is just higher order brushing. So instead of limiting your brushes to a single point or 2 points or 3 points, you have an arbitrary number of points. And the interaction is orthogonal to the normal brushing or the traditional brushing. In traditional brushing, the interaction is along the vertical axis. But in the higher order brushing paradigm, the brushing is more like sketch-based from left to right or from right to left, and follows an arbitrary number of dimensions. This is not limited to a single dimension. So the user can basically sketch a high-dimensional polyline and think about a pattern or a wave pattern that they might want to find in the parallel coordinates plot, and then click on that pattern and move around the parallel coordinate space to explore the data set. So that's the basic idea, and then everything else is just enhancements to that basic idea. So there's been quite a bit of related work in brushing for parallel coordinates. We're not going to go through it all, but if you look at the related work section of the paper, there are 20 previous papers dating back to 1980. There's also a section of touch-based brushing interaction with 4 previous papers. And of course, there's the classic XMDV tool. And basically, I know what a lot of you are thinking, actually. A lot of you are thinking, well, we can already do higher order brushing in XMDV, can't we? And that's partially true, but it's not a very natural interaction. So in XMDV, you can do what we call composite first order brushing, and we'll talk about that. But it's not very intuitive, it's very slow, and it doesn't allow you to explore the space with this arbitrary high-dimensional pattern. The data we're going to look at is from our industry partner, who they build database software for call centers, and they collect information about every call that's made to the call center and all the individual events that characterize all the calls. So a typical call to a call center, which we all know and love and really enjoy, we navigate a menu system typically, that's called the IVR, and then we're put on hold in a so-called queue, And then if we're very lucky, we talk to an agent, an actual person that works into the call center. And there may be some events that happen after that. For example, the agent may put us on hold if we're lucky again. We might get to speak, if we're really lucky, to a second or third agent, and so on. So those calls actually can sometimes get very complicated and last a long time. And QPC has these two special properties of calls. One's called a customer effort score, which is a derived metric to try to assess how much effort a customer has put into their phone call. And there's also something called a net promoter score, which is the actual score given by customers when they get a text saying, would you please rate or evaluate your call that you just had, your call center experience with us. The data set we're going to show is about 230K calls, so that's a typical call center, getting 230,000 calls per day, and it's very unevenly distributed. And that is partially the inspiration behind some of the features that we're going to show. So here's just an example before we look at the demo video, which shows the interaction. On the first axis, we have the start time of the call. On the second axis, we have the call duration. Then we have wait duration, agent duration, cost, and customer effort score. And these boxes are kind of a comic strip style illustration of the interaction. So a typical higher order brush will start from the left. The user will click on an axis, and then that will define the beginning of the higher order brush pattern, and then automatically a brush interval range will be suggested for the first axis. And then the user will click on the second axis, for example. It's also possible to skip axes. A brush interval range will be suggested, a default brush interval range of about 10% of the data, and so on. And so these images represent mouse clicks on the screen in a static image. That was our attempt to represent the interaction with a static image. And this is just one example that we'll show before jumping to the demo video, which shows the actual interaction. Here is a naive parallel coordinates plot visualization of the 230K calls, and it's very overplotted. And this is a higher order brush pattern, starting with a very high a time of day, which is very popular for calling call centers, and a very popular time to hang up as well. And then a higher order brush pattern that identifies a very special set of abandoned calls very quickly. So it narrows down 230K calls to a special set of abandoned calls in just a few seconds. And abandoned calls are something that QPC likes to look at because they want to minimize the number of abandoned calls. So let's look at the demo, which is a little bit more interesting than static slides, in my opinion. Okay, turn down the sound and then skip the beginning. So we call the points based on a single point zero order brushing, and then first order brushing based on 2 points, and so on. And we call the composite brushing the composite first order brushing. So this is what it looks like in action. So the user typically clicks from left to right, and then the parallel coordinates plot is updated at each click, at each interaction, and the user can then position the higher order multidimensional pattern interactively, left to right, up and down, and so on. This is an example of the user looking at a special class of abandoned calls. So that's a previously unidentified set of abandoned calls. Abandoned calls are not explicitly derived, but they're implicitly derived. And that is a particular set of calls where a person has called and only spoken to an agent for just 2 or 3 seconds. So that's something that the company didn't pick up on previously. And we can see a distribution plot that shows the density of polylines. So in this case, every call is represented by a single polyline. And you can see that the brush interval ranges are selected automatically. They have a default of about 10%, but they can be interactively adjusted by the user. And that's an example of the user translating the brush. What they've done is they've pinned down the first 2 axes, the first 2 dimensions, and now they're translating the brush from left to right. This is an example of what it looks like to have a composite logical or higher order brush. So there's a higher order brush on the bottom and another one on the top, and polylines that pass through either one of those brush interval ranges will be highlighted. So it's a higher order logical or brush. And you can see a special class of calls that have a high agent duration. This is a very, very brief comparison with the XMDV tool. I don't know if anybody has tried higher order brushing in XMDV before. I'm a big fan of Matt Ward's work, by the way. And then we added some enhancements onto the basic higher order brushing idea, and we probably won't have time to discuss them all. But one of them are dynamic interval range glyphs, so that's for overplotting. Those glyphs show are histograms, but they're angular histograms, so they show the density of polylines passing through the axes, and they show the average angle of the polylines passing through the axes. And there's an arrow glyph there as well on the top and the bottom of the angular histogram glyphs. And those indicate that if it's a large arrow, it means there's a lot of polylines below the brush interval glyph. So they indicate where a lot of the polyline intersections are along the axis. And they dynamically update as the user moves their brush up and down the axis. You'll also notice there's something called a smart edge along the brush too, and the edge of the polyline changes its thickness depending on the density of the underlying polylines, something we call a smart edge. We also support dimensional zooming, so the user can use that brush interval range to zoom in on a particular axis. You can see the axis being scaled, and then you'll see 2 indicators at the bottom and the top of each axis that say this axis has been scaled, and there are 2 arrow glyphs at the bottom and the top that indicate how many polylines have been scaled out of the scene or outside the brush interval range, and those polylines are shown as context. They're rendered off the screen and shown as context. We also added some statistical features and an autocomplete feature. So if the user's not sure about how to define their higher order brush, they can just click on autocomplete and it will draw an average brush through all the dimensions. And the brush interval ranges will be based on standard deviations, so the first or second or third standard deviations. So they can hit on autocomplete and then auto scale if they want to, which means that the dimensional zooming will choose the first standard deviation and then scale all the polylines and the dimensions based on the first standard deviation. And that's inspired by the uneven distribution of the data. So we're going to stop the demo there due to time constraints. There are some more enhancements. So the idea is a higher order brush with several enhancements that we call smart brushing for parallel coordinates. And it's also driven by a real industry application and a real industry partner called QPC. And we thank you very much for your attention today, and we're happy to answer any questions that you may have.
Thank you, Bob. We have time for one or two quick questions. Okay, I have a question. So you compared your tool to XMDV. Would all these operations that your domain experts did with the data, would it be possible to do it with XMDV, and just more complicated, or are there things that are currently not possible at all?
There are some things that are possible. So you can do a composite first order brushing, but you can't do, it doesn't support exploration. So once you've had your higher order pattern defined, you cannot just click and drag it through the parallel coordinate space arbitrarily and search for those similar polyline patterns.
Do you plan to do a formal evaluation to compare these two tools in terms of the effectiveness to explore the data?
We don't have, our evaluation was based on domain expert feedback from QPC, so this was really meant to be something that's not necessarily in this context for every single user, but a special set of analyst users. So we didn't make plans to do a general user study. It was mostly based on domain experts that were going to use the tool in practice.
Okay, if there are no more questions, then thank Bob again. Our next speaker